Now let's consider reference electrodes. There are several widely used reference electrodes. The first example is silver chloride electrode. Let's look at this electrochemical setup. Here on the left hand side, yeah, this is anode and silver metal and silver chloride solid is pasted on the surface of a silver, right? And then the solution is saturated with KCl solution, and it is connected through the salt bridge. Okay, the right hand side, the electrode material is platinum, and inside the solution contains ferrous and ferric ions. Okay, yeah, and we write the right and left electrode reaction here. On the right electrode, yeah, the ferric ion accept one electron to become ferrous ion, and from the table, the standard reduction potential is 0.771 volt. Okay, and we write the Nernst equation for this one, and E plus is given by this equation. Yeah? The potential is determined by the ratio of these two ions. Okay. In the meantime, the left-hand electrode reaction is this one. Silver chloride accept one electron to become silver solid and chloride ion. Yeah? Standard reduction potential is 0.222 volt. Okay, and also we can write the Nernst equation for this one. E minus is 0.222 minus 0.05916 log of chloride ion here. Okay, so this silver electrode potential only depends on the chloride ion concentration. All right, and what is the total the cell potential here? So now you connect silver and platinum electrode with some the electrical lead, and then you mm, attach, you read potential difference with this voltmeter. Okay, this voltmeter the value is given by this reaction, this equation here. Okay, but now let's assume in the left hand, yeah, this solution is saturated with KCl. In other words, the chloride ion concentration on the left hand side, right, is all the time constant. Okay, this chloride ion can be maintained constant, yeah, by saturating the solution with this KCl solid. Okay, so the cell potential only depends on the ratio of these two ions. Okay, these two ions. You understand? And here, this is the platinum electrode is behave as indicator electrode here. And platinum ion characteristic is this one. This is a red line. Yeah. Platinum metal concentration, platinum metal potential is not fixed at all. It changes a lot, right? Changes depending on, in this case, the ratio of these two ions. Okay. In the meantime, this silver electrode potential is fixed. Look at that. When chloride ion concentration is fixed, this silver electrode potential, silver chloride electrode potential is fixed. It is reference electrode, yeah, fixed at a certain potential. Okay, yeah. So you understand, right? Here, this is a reference electrode, and platinum is indicator electrode. All right. The potential of indicator electrode changes. All right. So this silver chloride electrode is one of the representative reference electrodes. Okay, why? Because it is very simple to make. Yeah? Here, so instead of we set up like this, and this part is this blue dashed line covered this part, is the reference electrode. Okay, and it can be made very simple, very so simple like that. You take one glass tube and make a tip at one end here, right? Tip, and then you put a porous plug for contact with the external solution here, right? This porous plug means that it prevents the this liquid leakage through this plug. Okay, but ions are moving freely through this plug. Okay, this is kind of a salt bridge. You see, salt bridge can be made very small like that. And here inside, uh, you uh, you fill the with liquid saturated with cashier. Okay, here you add the solid potassium chloride until you don't dissolve anymore. And here you take a silver wire here, and you put a silver paste, silver chloride paste on this wire here, right? So this is a silver and silver chloride electrode. Okay, yeah. And this one, there is a small hole to what to inject the liquid. Okay, or to drain this liquid. Okay, yeah. This is very this is made simple, right? This silver chloride reference electrode. Yeah? So anyone can make this electrode very easily. All right. Yeah. So for the for this reaction, we already seen that E0 value, standard reduction potential, is 0.222 volt, which means that when chloride ion concentration is what 1 molar, right? But usually this one, we saturate this one with potassium chloride, and chloride ion concentration is much higher than 1 molar, right? In the case, it is when it is saturated with potassium chloride, the potential changes to 0.197 volt. Okay, here, and this picture is another version of a silver chloride electrode. Right? This is very simple. Yeah? Very simple, and since this structure is very simple, and it can be made very small, right? You can make it very small. Take a very small glass tube, okay, and so you can insert this electrode to a small space, okay. And another representative reference electrode is called the saturated calomel electrode. In short, we call it SCE. Actually, the calomel is the name of this compound, okay? Mercury chloride, He2Cl2. This is white, solid, and it has been known for a long time, and people are called calomel, okay? And it undergoes electrochemical reaction. It accepts one electron, maybe I mean this half of this one, accept one electron becomes mercury, uh, liquid mercury and chloride ion. Under the standard condition, which means the 1 molar chloride ion, E0 value is 0.268 volts. Okay, but usually we saturate the solution with the potassium chloride. Yeah? The chloride ion concentration is much higher than 1 molar. In that case, that case is the saturated calomel electrode. Yeah? The potential is 0.241 volts here. Yeah? This potential is also only depends on the chloride ion concentration. All right, and this is the structure. The structure is more or less the same as silver chloride electrode. You take the glass tube here, and you put a tip here, right? And tip is filled with porous plug. Okay, this kind of salt bridge, yeah, as I said. And here the solution is saturated with KCl, and you take another solution here, another the glass tube here. Yeah? Glass tube here is there is an opening for the ion in and out. Okay, and inside this small tube, you put mercury chloride, and KCl here, the mixture of these three compounds. Yeah, and then on top of that, you put mercury, liquid mercury. Yeah? Since it contains liquid mercury, so it is not easy to handle. Okay, and it is more complicated to make, yeah, than the silver chloride. Anyway, this now you need a contact, electrical contact for silver chloride ion, chloride electrode. Silver wire itself it can be used as a wire, okay, as a connector. But here, since this is mercury, so you have to use platinum wire, right, to make an electrical contact here. Okay? So this one structure is a little bit complicated, and this one SAE is much the more expensive than silver chloride electrode. Okay, and it cannot it is difficult to make it small, right, because of this structure. Yeah? So price is more expensive. All right, but the HHCl and SCE are widely used reference electrode. Okay? Well, let's look at this scale. Yeah? This is a potential scale, and here 0 is the SHE, yeah? Standard hydrogen electrode potential, and silver chloride potential is here 0.197 volt, and SAE potential is here 0.241 volt. Okay, and then to monitor a electrochemical reaction, then you need reference electrode, yeah? And of course and then indicator electrode, and you measure the potential difference, yeah? 0 minus 0.417 volt with respect to silver chloride electrode, yeah, this one. And what's the potential of this one with respect to SHE? Yeah, it is very simple. Yeah, you 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 look at this scale, and here when you use this one as a reference electrode, you measure the you obtain the this value. Yeah, and this is the negative direction, and minus 0.417 volt. But with respect to this one, yeah, since this SHE is potential is 0 volt, and you have to add 0.179 volt, yeah, to obtain the potential with respect to SHE. Yeah, so if you add these two values, and then you get minus 0.220 volt. Okay, but if you use the SCE as a reference electrode, you will get minus 0.461 volt. Okay, because there is a potential difference, and to convert this potential to the potential with respect to SHE, you have to also add this value. All right, yeah, 0.441 volt, and then you get the same potential here. Yeah. So this is the potential is simply you add or you subtract the constant value. Okay? Quite simple. Okay, let's temporarily stop here.